Hello to every man magician. My name is Aaron Racer and this is Man Magic. Today we're going to have the other method that we can use for us to be able to factor perfect square trinomials, and that is the switch method. So we have here three perfect square trinomials. And now we're going to use that method, which is way much more easier compared to the scissor method and the ordinary trial and error method, because its difference is only to how are we going to manipulate those factors. In choosing those factors, in the ordinary trial and error method, we're already basing it by testing out those factors by putting two parentheses, and then right after, we're going to be picking from those factors we have lined up, and then erasing when those factors don't match or it doesn't get the middle term that we have right here. For the scissor method, even though we're drawing a scissor, even though we have saved some for time, we still have erased something. But what if your teacher tells you not to create any mess on your paper, or shall we say, simply no erasures? So that would be an extra challenge. Now, what you have then left is only one method that you can use for you to be able to factor perfect square trinomials as clean as you can. Because this time, if you have saved somehow some of your time in the scissor method, in this method that I'm going to show you today, we are going to save much more than the time that you have saved on the scissor method. So we're going to be having this first example. 8a squared plus 10a minus 42. Now, we're going to be integrating the concept of a proportion for us to be able to know what is the basic foundation of this switch method. Now, for sure, there are actually lots of things that can come into your mind right now. First would be, why is it called the switch method? Or does this method look like the ordinary trial and error method? Well, actually, the reason why it's called the switch method is because of its second to the last step, which you will see later. Now, for us to get what a switch method is, first of all, we have to integrate the concept of a proportion, because that's actually the basic foundation of this method that I will be introducing to you today. Now, a proportion, if you remember lessons in elementary days, a proportion actually is a mathematical statement composed of two ratios separated by an equal sign. Now, we're going to be integrating that concept for us to be able to check if we're actually getting the answer of this middle term that you can see right now. Now, there are actually two ways on how we can perform this switch method. The first one would be horizontally, and the second one would be vertically. So both ways would arrive at the same answer, and both ways are very simple to use. Now, let's start with getting the factors of 8a squared. So the factors of 8a squared are none other than 2 and 4. Oh, by the way, we're going to be using the horizontal method. All right. And then another factor for 8a squared, eliminating the a squared, we're going to be having 1 and 8. And then for 42, its factors are 6 and 7, 3 and 14, 2 and 21, and 1 and 42, of course. All right. Now, I can already do the switch method by just integrating the concept of a proportion here by multiplying the means and the extremes here. But first of all, we have to elaborate further how we're going to be performing that step. Okay, so let's put or rewrite 2 and 4 and 6 and 7 here. All right. Now, we're going to be putting the column between 2 and 4 and another column here between 6 and 7. And right after that, we're going to be putting that equal sign. Right. Now, you can see from here the means and the extremes. The means are the two factors or two terms that are nearest to the equal sign. And then the ones that are far from the equal sign are what we call the extremes. So we're going to multiply the means and combining it to the product of the extremes. So 6 times 4 is equal to 24, and 2 times 7 is equal to 14. Now what we want here is to get the answer of the middle term, which is 10a. And that is already possible from the answers that we got. By making one of these terms negative, we can be able to achieve positive 10. And that is by making the smallest number to have that negative sign, which is positive 14. Now it becomes negative 14 because of the negative sign. And that's it. 24 minus 14 can obtain positive 10. Now, our next step would be the explanation to why is it called the switch method. It's because we're going to be switching the places of the two terms in the means, that is for the 6. So already in the parentheses right now, perhaps it's already the second to the last step, and the last step would be explained later on. So we're going to be putting the two terms that are not going to be touched anymore, that is 2 and 7. And then switching places, we make 6 here in this first parentheses and 4 for the next parentheses. And then analyzing to which parentheses shall we put that negative sign, right? Because we have here negative 14. Which parentheses will have that negative sign? Well, first of all, if you put that negative sign as your answer for the product of these two factors in the extremes, then definitively your negative sign will be placed in the second parentheses. But if you put the negative sign on 24, which is the product of 4 and 6, and in other words, you place a negative sign on the terms of the means, then in conclusion, you're going to get the first parentheses to have the negative sign, right? But for this case, we have the negative sign on the second parentheses. And for the first parentheses, we have the positive sign. Now, let us put on these variables. We have here A and A. And there you go. And these are the factors of the perfect square trinomial. Easy, right? Let us now use the vertical way on how we're going to be performing the switch method. All right. Now, for the vertical method, we're going to be lining up the factors of 8, a squared here, or just 8, and then the factors of 42. All right. Now, factors of 8, we have here 2 and 4. Oh, wait, sorry. 2 and 4 and 1 and 8. And then factors of 42, we have here 6 and 7. And then 3 and 14. 2 and 21. And 1 and 42. Now that we already understand how we can use the concept of a proportion in order for us to and understand the switch method, we can now use this kind of method in a vertical way. Let us try another set of factors, that is 1 and 8 and 3 and 14, for us to do the vertical method. Now, same thing, we're just going to multiply the means and the extremes. Write it properly, so all we have to do then is just to draw a bracket here that will actually be a bit curved. Okay, there you go. So we're going to be multiplying the two means first. We have here 8 times 3, which is going to be 24. And then 1 times 14, which is equal to 14. So what we're going to be doing here is that we're just going to be putting our answers here. So 8 times 3 is equal to 24. And then 1 times 14 is equal to 14. And there you go. We're actually also getting the answer of 10. 8, or just 10, by actually making 14 negative again. So, writing our parentheses, we're going to be putting 1 and 14, plus switching the places of 8 and 3. And then because the negative sign is on positive 14, we are going to place the negative sign on our second parentheses, same as our first answer with the in which we use the horizontal method. And then positive for the first parentheses, and then integrating the variables. Instead of 1, this is just going to be letter A. And then for 8, so we'll also be having that letter A. Okay, so our answer then is 8 plus 3. 8 plus 3 multiplied by the quantity of 8a minus 14. And this is another factor of this perfect square trinomial. Then we have here the second perfect square trinomial, that is 24x squared minus 12x minus 12. Now, if you notice, this example actually came from our example in the scissor method, and we're going to be using this example again in our switch method. If you guys wanted to try using the switch method by yourself, then feel free to do so. Or if you want, we can actually do it together. Okay, so we're going to be using first the horizontal method, or we can actually make the vertical method first. Now, factors of 24x squared, eliminating the x squared, the factors of 24 are 2 and 12, 3 and 8, 4 and 6, and 1 and 24. Right now, these are the factors of 24. Okay, now for 12, its factors are 2 and 6, 3 and 4, and 1 and 12. Now, as you can see, everything is perfectly lined up, except for this one because it's actually slightly. Now, integrating the same concept and performing the same method, we're going to multiply the means first, wherein 12 times 2 is equal to 24, and 2 times 6 is equal to 12. Now, what do we want to get here? Negative 12x, or just negative 12. And we can actually achieve that. How? If a while ago, our middle term has a positive sign, and then for it to become positive, or for it to stay positive, we need to have the lesser number to have the negative sign. But this time, because our middle term has the negative sign, we would do the opposite. The greater number would carry the negative sign. That would be negative 24 plus 12, in which our answer then would be negative 12. And there you go, we already got our middle term. Now, writing our parentheses, and then switching the places of both 12 and 2, making 2 be placed in this parentheses while 12 on this other parentheses. And this time, because 24 has the negative sign, then it must be that first parentheses to have the negative sign. Right? So the other parentheses then would have the positive sign. And then inserting the variables, we're going to be placing x on both the first terms of every parentheses. And there you go. These are the factors of this perfect square trinomial. Next, we can actually do that horizontally. Integrating the same concept. 2 times 6 is equal to 12, and 12 times 2 is equal to 24. So I actually multiplied 2 and 6 first so that we can be able to put our answer on top. And then we will not be confused on what parentheses would have the negative sign. Alright, so we can actually achieve the answer of negative 12 if we would make the greater number have the negative sign, that is positive 24. Now it becomes negative 24. And so, readying our parentheses, making the terms on the extremes, we replace on opposite sides of the parentheses. Okay. And then switching the positions of the terms in the means. And there you go, we achieve the same answer. Right. So our answer would be 2x minus 2 multiplied by the quantity of 12x plus 6. Now, before we start this last example that we have, we can conclude that once the negative sign is placed on our answer by multiplying two means, then the first parentheses would have the negative sign. But if it's the opposite, if we're going to integrate that negative sign once we multiply both of the terms in the extremes, then it is the second parentheses carrying that negative sign. So in summary, this first parentheses is for the negative sign in the means, or in the product of the means, and the second parentheses is for the negative sign placed before the product of the extreme. Now we have here 21q squared minus 29qr plus 10r squared. If you guys want to try it yourself, feel free to pause the video. Okay, now we're going to be using any kind of method here, but we're going to choose the horizontal method. Right? Now, factors of 31 squared. Only 3 and 7 and 1 and 21. Factors of 10r squared, or eliminating that r squared, we're going to be having 10, and its factors are 2 and 5 and 1 and 10. Alright. Let's try first these last two pairs of factors. If you 1 and 21 for as factors of 21, and 1 and 10 as the last pair of factors for positive 10. Okay. Now, multiplying the terms in the means, we have here 21 times 1, which is 21. And terms in the extremes, 1 times 10, which is equal to 10. Can we be able to get negative 29? No, we can't. Whatever we do, whether we make one of these negative or and the opposite positive, we cannot be able to achieve negative 29. If we encounter these kinds of things, But once we get to achieve the wrong pair of factors, or once we manipulated the wrong pair of factors, all you have to do is just to underline these one, for example, 3 and 7 and 2 and 5. And then you can either draw an arrow, or if your space is short, you can just multiply the two factors here, just like how we did it a while ago. So 3 times 5 is equal to 15, and 7 times 2 is equal to 14. Can we be able to achieve negative 29? Yes, we can. How? We're going to make both of the numbers negative. So negative 15 minus 14 can achieve the answer of negative 29. Now, because both of the terms have the negative sign, this means that both parentheses will have a negative sign. And so, placing the two untouchable terms, which are the terms in extremes, and then our two other terms here in the means, which would be switched on its places, which are 2 and 7. Inserting the variables, and that's it. These are the factors of this perfect square trinomial. So once you test the factors, it's going to be like 2 times 5, which is equal to 10. And then 3q times 7q, which is 21q squared. And then negative 2 times 7 is equal to 14. 3q times negative 5, which is negative 15. And there you go. You're going to get the answer of negative 29. QR. So that's it. And that's how we use our second and the last method that we can use for us to be able to factor perfect square trinomials. See you guys again in another video of Math Magic. My name is Aaron Racer. Telling you stay safe and keep following Math Magic. Bye!